Okay, so we've finished with line graphs now, but what we're moving on to now is looking at pie graphs, pie charts. Now, some of you may know what a pie chart is. It is a circular diagram used to show proportions of the total number. So it shows the fraction within the diagram. Now, one fact that I love, which I don't know how true it is that supposedly Florence Nightingale was the first person to actually use a pie chart to demonstrate data during the Crimean War. I don't know whether it's true, but I think it's a nice little fact if it is. Now, for today's lesson, we're not going to be working with pie charts. We're going to be developing our understanding of circles so that you can use that knowledge to then tomorrow work on calculating with pie charts. So today is purely about what a circle is, how a circle is made up, and how you can interpret information within it. Okay, so if we're looking at this diagram of the circle, we've got lots of different parts of the circle. Okay, now the outside area or the perimeter of the circle is known as the circumference. So I'm just going to draw into there. Okay, so the circumference, if you think of the word circle and circumference, they come from the same root word, so it just means it's the outside edge of the circle. Okay, now obviously another word that you will know, which is centre. We all know what the centre is. We use it a lot in all sorts of different lessons. So the centre is this part here, right in the middle, and it is crucial to know where the centre is when you're actually working with circles. Now, I'm just going to get rid of these lines because it's going to get a bit more confusing if I leave too many of them on. Now, when we're thinking about diameter and radius, which are the two new words, they are very much linked. So if we're thinking about the diameter, it is this line here. It is the line that goes across the centre, using that word again, the centre of the circle from side to side. So it crosses the entire width of the circle, but the point must go through the centre point. If it doesn't, then it isn't a diameter. Now, the other word that we're looking at is radius. Now, the radius is the distance from the centre point to the outside edge. Now, it could be anywhere. So if I did a line from there to there, that is also the radius. That is also the radius, okay? As long as it goes from the centre to the outside. Now, hopefully, what you can notice is that the radius is half of the diameter, okay? So radius, oh, pen's not working. Radius equals diameter divided by 2. But you can also use that to work out that diameter equals radius times 2. Now, those are two key facts that you're going to need during this lesson because you're going to be calculating with the radius and with the diameter, just so you get the idea of how they are linked. But the key point to remember is the radius goes from the centre point, the diameter goes through the centre point. Okay, so we're going to use those facts that we just learnt. So remember what I said. So radius equals diameter divided by 2. Diameter equals radius times 2. So we're going to use those two facts to help us complete this table. So if I've got the radius of 26, to work out the diameter, it's going to be 26 multiplied by 2. So 6 2s are 12, 2 2s are 4, add the 1 gives me 5. So the diameter of that circle would be 52 centimetres. Now, if we're working out the radius from the diameter, I've got to divide by 2. So 37 divided by 2. So 2's into 3 goes in once, with 1 left over. 2's into 17 goes 8 times, but I've still got something left over. So I've got 1 left over. 2's into 10 go in 5 times. So on this particular one, note the change in unit of measurement would be 18.5 millimetres. So working on this one, we've got 2.55 metres as the radius. Times that by 2. 5 times 2 gives me 10. 5 times 2 gives me 10. Add the 1 gives me 11. 2 times 2 gives me 4. Add the 1 gives me 5. So that is 5.10 if you want to, metres. Next one, 99 centimetres. So we've got the diameter. So we're dividing by 2. So 99 divided by 2. 2 into 9 goes in 4 times with 1 left over. 2's into 19 go in 9 times, also with 1 left over. 2's into 10 go 5. So that's 49.5 centimetres. And the last one that we're going to do is also a converting diameter to radius. So we're going to divide by 2. So 19.36 divided by 2. So 2's into 1 don't go. 2's into 19 go 9 times. There's my decimal. But I've got 1 left over. 2's into 13 goes 6 times. Again with 1 left over. 2's into 16 go 8 times. So my answer would be 9.68 centimetres. So hopefully you can see how the two work together. You can multiply up if you've got the radius. You can divide down if you've got the diameter. So we're looking at this one. We're actually thinking about it as a problem. So Alex says the bigger the radius of a circle, the bigger the diameter. Do we agree? Well, if we're thinking about it, if I have got a radius of 5 centimetres, the diameter would be double that. So it would be 10 centimetres. If I've got a larger radius at, let's say, 10 centimetres, my diameter would be double that, would be 20 centimetres. So the logic behind that is perfectly sound. The bigger the radius, the bigger the diameter. And it does work in reverse. The bigger the diameter, the bigger the radius. Okay, so if you remember back to the first slide, I talked about how the centre point of the circle is really important. Now, on this one, that is the case. So Tommy has measured and labelled the diameter of the circle below. He thinks the radius of the circle will be 3.5 centimetres. Now, he's got a nice line going across it, but it's not going through the centre point. Okay, so if he had the diameter going through the centre point, excuse my wobbly line, that's going to be considerably longer than the line he's actually measured here. So it does make a difference. So this circle has a diameter probably of maybe 10 centimetres. Okay, so it does make a massive difference. So his issue, his problem, was that he didn't go through the centre point when measuring the diameter. Right, so this particular question is looking at ways of manipulating the information that you were given based on fractions. So this first section up here, the top of it, is actually really important. So here are two circles. Circle A is blue. Circle B is orange. So we could label it if you wanted, if that helps make it easier. The diameter of circle A is 3/4 of the diameter of circle B. So that's the relationship between the two. A is 3/4 the size of B. You're using that information, and this 3/4 is really important. If the diameter of circle B is 12, what is the diameter of circle A? So if we're looking at this, B is 12. So we know that A must be 3/4 of 12. So we've got to find out how to do that. Now remember, when we're finding a fraction of an amount, we divide by the bottom and times by the top. So we're going to do 12 divided by 4, which equals 3. And then we're going to multiply by the top. 3 times 3 equals 9. So I know that the diameter of circle A is 9 centimetres. Right, now if we're looking at this one, we've got, if the diameter of circle A is 12 centimetres, what is the radius of circle B? So we've actually changed what we're looking for. So don't fall into the trap of asking or looking for the wrong thing. So if circle A equals 12 centimetres, and we know that A is 3/4 of circle B. Now, we've got to work backwards from here. So 12 centimetres is 3/4. Now, we've got to find 4/4 because that's the whole thing. So what I'm going to do is I'm going to divide by the numerator and then multiply by the new numerator, which would be 4 in this case. So 12 divided by 3 gives me 4 centimetres. And 4, because now I want 4/4 multiplied by 4 equals 16 centimetres. But that has given me the diameter, not the radius. So now I've got to do another step, which is halve that. So 16 divided by 2, which will give me 8 centimetres. So the diameter for this circle would be 8 centimetres. So there was quite a lot to actually do for that problem. Right, third question on this set of problems. If the diameter of B is 6 centimetres, so we know that B is the whole amount, A is 3/4 of that, so we want to work out the diameter of circle A, so we've got to do 3/4 of 6. So I'm going to divide by 4. So 6 divided by 4. 4's into 6 go in 1 time, with 2 left over. 4's into 20 go in 5 times. So actually, my 1/4 of that is 1.5. Now I've got to multiply it by the 3. So 1.5 multiplied by 3. 5 3s are 15. 1 3 is 3. Add the 1 is 4. Don't forget your decimal. It's not 45, it's 4.5. So the diameter of circle A in that scenario is 4.5 centimetres. Now, the last question is very similar to question 2. So we're looking for the radius and not for the diameter, but we've got to find the diameter first. So we've got the diameter of circle A is 6 centimetres. What is the radius of circle B? So for a start, we need to find the diameter of circle B. So 6 centimetres is 3/4 of B. Okay, we need to find 4/4. So that's what we're aiming for. So to start off with, I'm going to find 1/4 by dividing it by 3. So 6 divided by 3 equals 2. But now I'm trying to find 4/4. So I'm going to do 2 multiplied by 4 gives me 8 centimetres. Now, sorry, that's not very clear, is it? Okay, that's my diameter, but I'm looking for the radius. So what do I do to find radius? I've got to divide by 2. So 8 divided by 2 equals 4. So the radius of circle B would be 4 centimetres. So now what I want you to do is to have a look at the question sheet that's attached to your home learning and have a go at some questions which will be fairly similar to this.